Hi, everyone. I'm Marco Gatti from University of Pennsylvania. And this is about doing cosmology using and combining different non-Gaussian statistics applied to weak lensing data from the dark energy survey. For this analysis, we relied on a likelihood-free inference framework, and that was the only way actually to do this with the complexity we wanted. Now, for a likelihood-free inference framework, of course, you need to rely on being able to forward model your observables, which for weak lensing data and compare them to the data. And for weak lensing observables, this comes in two steps. The first steps, of course, you need to run many n-body simulations. And that's what we did. We spun a 7 cosmological parameter space. So it's a WCDM plus neutrino analysis. And after you do this, you need to be able to forward model your weak lensing mass map. And we know how to do this. And when you do this, you also need to include all of your observational and astrophysical systematics. And here there's a list of the things we included. And the main message I want to convey here is that now this is kind of a benchmark. We know how to do this, and we're including the same systematics standard cosmic shear analysis are including in their analysis. So that's pretty reliable. After you're producing your weak lensing mass maps, you can measure a number of non-Gaussian statistics. These are all the statistics we included in this kind of analysis, and we are combining all of them. And this is kind of a first time this has been done, and this is possible because of this simulation-based and framework. In order to go from here to the cosmological parameters, there are 2 extra steps. The first one, let me skip this, is a data compression. We're using neural network compression. This is pretty standard to reduce the size of the data vector. And the second step is about estimating the likelihood surface using neural density estimators trained on our noisy mocks. And this basically allows us to use a significantly less amount of simulations compared to standard emulator approaches. Does this method work? Yes, we did many tests. The first one on the left here, we check the size of the posterior is correct. This is an empirical coverage test that says that the size of the posteriors is good at the few percentage level. And on the right, we also compare against standard Gaussian likelihood approaches for Gaussian statistics. And the fact that 2 contours matches means that our pipeline reproduces what we're expecting to reproduce. Finally, this is a simulation test. We're gonna unblind in a few weeks, so very soon on data. This is basically the results on S8 and omega matter, combining all the non-Gaussian statistics in gray compared to the red contours, which is standard Gaussian statistic. And as you can see, this is a very powerful approach. The figure of merit will be improved by a factor of 2, basically. And this is the first time all of this will be applied to data. So stay tuned for the actual results in a few weeks. Thanks.
Thank you very much, Marco. I think we have the coffee break now. I'm asking our colleagues in Paris, so what time do we need to come back?
Yeah, let's come back at 5 p.m., didn't we say?
5 p.m., so 11 a.m. here.
5 minutes before 5, and we'll make a short announcement, at 5 minutes to 5, 16:55. Thanks, Paco, for your help and organizing things on your end. It worked reasonably well, I think, for the first session. So thanks for all the speakers again.
Thank you. Thank you again.